Welcome to Volterra Multi or Hybrid Cloud Networking. This is a demonstration of Volterra CE to CE full mesh. Before you get into the demo, let's review a few terms and terminology. RE or Regional Edge, also known as Point of Presence. CE, also called as Customer Edge, also known as Site or Volterra Nodes. Site Mesh Group. Site Mesh Group is a configuration object to connect the CE to another CE using the IPsec or SSL tunnel. Virtual Site. It is a collection of CE or sites to reduce the needs to repeat the same sets of operations. For example, when you want to create and deploy a configurations, you can apply the configurations to the virtual sites. Advertise or expose or publish apps. What I mean is that you're making an applications available and accessible based on your desired intent. From a high level, there are two types of CE connecting patterns. Pattern number one is the regional edge pattern. When a CE spin up, CE will automatically register to the RE. Generally, it will establish two IPsec tunnel to two different RE. And secure global backbone will be used as the transit from a CE to the other CE. What I mean is that when CE on one data center or on one cloud required to communicate with another CE or resources that behind the CE, if you leverage the secure global backbone as the transit for the data path. This is the second pattern where this is a CE to CE full mesh. In this pattern, a CE on a site will establish an IPsec tunnel with a CE or a group of CE defined in the configuration and form a full mesh. For this pattern, customer can leverage on their existing backbone or internet for CE to CE communication or data path. Volterra SaaS, which hosted on the Volterra backbone, will be the backup data path as well as the management and control plane for all the CE. In this pattern 2B, it is similar with 2A except that the topology created is a hub and spoke, where spoke site, which consists of many CE that is got spun up, are connected to the hub site. These hub sites are running in full mesh. Let's follow these few simple steps to set up a full mesh connectivity for patterns 2A. Alright, before you can configure this CE to CE full mesh, first you need to deploy CE or sites or Volterra nodes. For public cloud nodes, you have to use the assisted deployment. Automated deployment for this setup is not supported. Please refer to the Volterra documentations on the details on how you can deploy a CE with an assisted mode. For on-prem or edge, you can just load the OVA file for VMware or the ISO for the KVM. Then once your site are spun up and enroll and register onto the work console, what you need to do is that you need to configure the CE tunnel IP addresses for each CE. Then what you need to do is that you create a virtual site or a group of related CE with a label. So if you are spinning up, let's say for example 5 sites, all these 5 sites you can group them as a logical group and you can label the group with a label. Once you have did that, the fourth step is that you create a site mesh group. This site mesh group is basically a configuration object and you reference the virtual site that you have created in step 3 as part of this site mesh group. Once you have did that, Volterra CE will try to establish a site-to-site tunnel between each other and you can validate the CE to CE full mesh tunnel from the dashboard. Once these things are done, when all the connectivity are working or up, your applications are ready to be advertised. This is just an example of the configurations. Looks like in a full mesh setup. This is the topology that we are trying to set up in this demo. Let me walk through quickly on how all these things will interconnected. I have an on-prem data center. I have Azure. AWS in Sydney, AWS in Singapore, in the US East, as well as in GCP. So in all these sites, I already spun up all the WAP mesh, or all the CE or WAP mesh are already spun up, and I have a server running behind in each of this site. And I will follow the same example as what I explained just now to set up the CE to CE full mesh connectivity. Let's look into the configuration. Once you log into the WAP console, go to site list. This is all the sites that already have WAP mesh installed. Once you have the sites deployed, or the CE sites deployed, the second step that you need to do is that you have to go to the three dot, click the three dot, edit, and specify the tunnel IP address, site-to-site tunnel IP. This site-to-site tunnel IP is the public IP address that you specified for your particular node. In my case, because I'm using the internet as the transit, so this IP address will be the IP address of the public IP of my site. Do the same for the rest of all the site or all the CE. Once you have that set up, now the third step here is that you need to create a virtual site and group all the sites under one virtual site. If I go to the share, go to the virtual site, I already have created one here. Let's say, for example, if you want to create a virtual site, you click add virtual site, give the virtual site a name, select the site, whether it's a RE or a CE. In this case, it will be a CE. And you can create a site selector expression. In my case, I call that site name, and I call that site mesh-CE. Once you have that, you click save and exit. I'm not going to do this because I already configured that, which is this one. So you can see the configurations that shown at the bottom here, that the expressions that I'm using is site name, site mesh-CE, and the type is customer H. All right, once you have the virtual site created, you need to label the site as part to create a virtual site. So what you need to do is that you go to the system site list, go to the respective site or CE, click the three dot, edit, and label your site to have the same site name called site mesh CE. Do the same with the rest, site mesh CE. Once you have did all this, if you go to the application tab, virtual site, and look for your virtual site, site mesh site, you can see that I have a total of 6 sites within this virtual site. If I click in, you can see that my sites, as I mentioned in the beginning, I have one in AWS US East, I have 2 in Singapore, one is the AWS Singapore one, and the other one is a GCP Singapore 3. As well as I have the some site here. This is in Sydney. I have Azure as well as AWS, and I have another one in Melbourne that is running on the VMware on-prem. Now I have my virtual site, and I have already labeled all my CE with the label. Next, what you need to do is that you need to go to the system, under networking, site mesh group. You need to create a site mesh group. I already pre-create a site mesh group. If I look at what is being created there, this is a full mesh, and you reference the virtual site that you created for the site in this group. And you can leave the hub blank because we are doing the patterns 2A, which is not a hub and spoke. This is a full mesh, and the tunnel type is IPsec. Save and exit. Once you did that, you can validate to make sure that all the IPsec tunnels are established and running by logging on to the dashboard. I already pre-logged on to one of my on-prem CE. You can see that all these tunnels are up and established. For example, if I want to reconfirm, let's say if I jump onto the other one, did the same thing as well. 6. You can see that this is the Azure, and you can see that all the tunnels are up and running. By default, once there's a site-to-site tunnel, any data path from one CE, when they want to talk to the other CE, the tunnel, site-to-site tunnel will be the priority. If the site-to-site tunnel are down, then what happens is that from one site to the other site, it will use the Volterra global backbone as the backup to get to the other side. All right. Now, once you have that set up, now now you can start to advertise your application. Now, how you can advertise your application? You go to the application tab. You need to set up the origin pool. The origin pool basically is the server that is running behind the web mesh that you want to advertise that. For example, I have set up the origin pool for all the server behind the sites. For example, I have a US East AWS Speed Server Pool 1. If you look at that, I specified the IP address of that VM, and this is in the AWS East 1, and it is listed on port 80. Alright, once you have the origin pool set up, you need to set up the HTTP load balancer. We are using a layer 7 services to advertise our application from one site to the other. For example, I can create this US East AWS load balancer, and I give it a domain called useast-aws-walk.demo.local. This is just a local FQDN that I created, and you can specify where you want to advertise. In this case, for example, I say advertise custom. I advertise it to web mesh CE1. This web mesh CE1, basically it is a web mesh that is run on the Melbourne lab. For example, if I'm trying to run this is on the Melbourne on-prem. I already pre-log in. If I look at the host file, so all this FQDN, right, is actually pointing to the web mesh. 10.01.0.21 is the web mesh. So if I do a curl HTTP to this one, so what it means here is that actually I'm hitting my local web mesh, and my local web mesh is tunneled to the US East AWS. So this is the US East web server that I already running. I just put a text there, welcome to US East AWS web server. You can see that from my on-prem, Melbourne on-prem, I'm connecting to this FQDN, which is on the web mesh, local web mesh, and the local web mesh will tunnel and send it to there. Let's say if I did the same thing as well for the Sydney Azure, if I get the host file as well, if I do the same thing, if I do a cat here, curl. Oh, alright, so this one is actually denied. If I check the header, it's actually 404 not found. The reason why it is not found, because for this US East AWS LB, I only advertise it to the on-prem Melbourne on-prem. Let's say, for example, if I add, I can say that I want to advertise it to the Azure site. The rest I can leave it as default. If I click apply and save. Alright, so what I mean is that for the US East AWS load balancer, I had allowed that services, this one, to be exposed to the Azure, Sydney Azure. If I run the same command again, you can see that I can access the web server on US East AWS by pointing this FQDN. This FQDN is actually, let's say if I cat etc host, this FQDN is actually pointing to the local web mesh. So what I mean is that from my Ubuntu box, my local server, I'm pointing to the web mesh on this FQDN, and this FQDN hitting my local web mesh, and my local web mesh via the secure IPsec tunnel send the traffics to the US East AWS server. This is one of the methods that you can establish, and you can expose your application via the layer 7 services. There's another way that you can expose the applications from one side to the other side is via the layer 3 routing. Let's go through how you can create a layer 3 routing. The first step is that you have to create what we call a virtual network. This virtual network is equivalent to a VRF. What you need to do is that you go to the networking, virtual network. You create a global network. What I did is that I already created a virtual network and configured it as a global network. Once you have a global network objects created, what you need to do is that you have to associate all your site or all your CE and all your CE to be part of this global network. How you can do that is that what you can do is that you can create a network connector. In this example, I create a network connector called Foops Site Mesh Net Connector, and I specified that this network connector, Site Mesh Net Connector, is part of the global virtual network, Foo-Bang Global. So once you create a network connector, you create a fleet, and you associate this network connector as part of the fleet, and you can apply the fleet into the site or the CE that you had. So if you go to the site management, go to the fleet, and what happened here is that I created a Foo-Bang site mesh fleet. In this fleet, I specified that I'm using this Foo-Bang site mesh net connector, and basically this fleet will have this global networks site mesh net connector. So the rest you can leave it as default. Once you create a fleet, you associate the site with the fleet. The same thing, you go to the site list. For example, for example the AWS East one, you click on the three dot. You can see that under the site, under the fleet, I specified that this is the Foo-Bang site mesh fleet. Do the same for the rest as well. This is the Foo-Bang site mesh fleet. Let's say, for example, if I look at another example, let's say the GCP will be the same thing as well. You specified the Foo-Bang site mesh fleet. So what happened is that once you created the layer 3 to validate that indeed the layer 3 is created, you can go to one of the site. Let's say, for example, if I go to the AWS SG1 site, you go to the tools, and you can validate the show routes, the routing. Site local insight, show routes. So from here, you can see that there's an MPLS tunnel encapsulations via the MPLS over UDP. You will see these additional routings being created in the routes. You can confirm that the rest will have the same thing as well. For example, if I do the media to the GCP, you click this one, tools, and show routes, and local insight. Because what happens is I'm connecting my site local insight to the global network. So if you do a show route, you can see that the MPLS over UDP route is being created. All this prefix route is actually the routes or subnet of the other site, and they are tunneling while the MPLS tunnel. So to validate, now you can see that the routes are there. So as long as you make sure that the routes from, let's say, for example, from here, if I look the route, let's say, for example, this US East IPA. This US East IPA is 10.1.2.238. So what I need to do is that from here, if I need to set up a route, potentially I already set up, 10.1.2.0 via 10.201.0.21. Remember that 10.201.0.21 is actually the Warp Mesh IP address. Remember that we have 10.201.0.21. This is the Warp Mesh IP address. So in the routing table, what we are saying that if you want to get to 10.1.2.0, go via 10.201.0.21, which is my local Warp Mesh. And once it hit my local Warp Mesh, my local Warp Mesh will route it to this 10.1.2 subnet. And of course, on this machine, I have to make sure that for my Melbourne lab, I am using 10.201.0 subnet. Here, I have a route defined as well, 10.201.0, send it to 10.1.2.26. 10.1.2.26 is the local Warp Mesh in the US East. So now what I can do now is that if I do a ping of this IP address 10.1.2.238, 10.1.2.238, you can see that from my Australia Melbourne on-prem, I can ping directly to the box here. Or if I want to do it, I can in fact SSH. This is Ubuntu. I may not be able to SSH because I may not have the key there. I don't have the key. Maybe this one. Oh, okay. So yeah, I actually log into the AWS US, or I can remember that I also can do a curl to the IP address of this one. Curl HTTP. Yep, you can see that I'm getting the US East web server by, like, it seems like this IP address is just next to each other, whereas this US East AWS is actually far away from Australia. It's happened the same thing for this node as well. If I do this IPR 10.1.2, I point it to my local Warp Mesh routing as my gateway to the other side. So the same thing if I do a ping 10.1.2 192.168.168.238. I can ping from my Azure. My Azure IP address is 10.5. That's why in here, the same thing as well. It's all routing, layer 3 routing. I have 10.5.1.0, send it to the local WAP mesh. So the same thing if I call http / 10.1.2.238. Yep, you can see that I can get to the US East web server. So this is another way that you can expose your applications, or by doing the layer 3 routing. Thank you for watching.